Okay, so here's an example that I find very interesting.
The experiment shows, the experiment shown here is a way of measuring surface tension of a liquid. A thin wire is bent into the shape of three sides of a rectangle and fitted with a sliding wire as the side. Film of the liquid covers the loop established by dripping the fluid into a container of liquid. The surface tension will tend to draw the sliding wire down. We apply an external upwards force P necessary to maintain the sliding wire equilibrium. The upward force must balance the downward forces, the weight mg, and force F due to surface. In one experiment, it is found that the movable wire in equilibrium when the upward force P is 3.5 times 10 to the negative 3 newtons. The wire has length 4.85 centimeters and a linear mass density of 1.75 times 10 to the negative 3 kilogram per meters. Find the surface tension of it.
Do you get it? So there is a box that we've constructed with a wire, and we've cut off the top. And then on the fourth side, we have a sliding wire. So when you press this into, it's like, have you played with those soap bubbles, right? When you were little? Well, how do you make a bubble? You dip it in, right, to the soap solution. Then it gets onto the surface, and then you do this, right? And the soap just makes those bubbles. So think of it that way. But in this case, there is a sliding wire that slides down as long as there is a surface that exists for it to be held up, right? So in this surface, there will be an upward force P that they give us that the surface has to apply to make it go up. There will be a weight, as always, of this wire that's acting downwards, right? And then there will be a force that acts downwards. Color change.
Green.
Okay, green. Thank you. That will act downwards. Bring it down due to the surface tension. So which force are we looking for?
P.
That will help us find surface tension, right? So remember our formula for gamma was force per unit length. That's the force we're looking for. So as always, where should we start? Our favorite place. Sigma F equals, pick a direction, guys. Okay, done. X and Y. Okay, so that means sigma F will be P up minus mg minus F. Things going anywhere? So will I get F equals P minus mg? I gave the definition of gamma as F over L. May I write gamma L as F? What is L in my case? Is this my L? And that they gave me as D here, right? Okay, do they give me a value for D? Yep. Also, how many surfaces will there be? If I'm holding this up, how many surfaces will I get? Think about it. 2, right? 1 at this surface, 1 at this surface, and 1 on this surface, right? Because we have to have, it's just like a soap bubble. How many surfaces does a soap bubble have? 2. 1 on this side and 1 on that side. Okay, so may I replace this L by 2D? So will my force be gamma 2D equals F? Which then I can plug in here. What do I get? 2 gamma D equals P minus mg. What am I looking for? Gamma will be P minus mg over 2D. Do they give me P? Yes. Do they give me length? Yes. Do they give me linear mass density? Oh, what is linear mass density? M over L? Can I find M from there? Plug them in and you're done.